Hello everyone, welcome to my channel. In SD&Beat, I do share network automation and programmability content, and in this video we will be talking about SD-WAN, which stands for Software Defined Wide Area Networking. SD-WAN is basically WAN plus SDN, meaning it's an SDN implementation on wide area networks. So let's start by talking about traditional router and traditional networking in general. So let's assume this is our traditional router, meaning non-SD-WAN router. A traditional router on the WAN edge, connected to a lot of WAN circuits, had to be very powerful when it comes to hardware. It had to have a decent switching backplane power and also CPU, RAM, storage, everything else, basically. So also a traditional router, because it doesn't have SDN concepts implemented on it, it has control plane and data plane coupled together. So let's assume that this is our data plane, right? Let's extend it a little bit. And let's assume this is our control plane. Okay, that's our control plane, right? So this is traditional router. Traditional router, as you can see here, have control plane and data plane coupled together. An SD-WAN router is different. Let's assume we have an SD-WAN router. This is SD-WAN router. And it also has this concept of control and data plane. However, in SD-WAN router, we decouple the control plane and put it far away for now. Now we just have a data plane. What does it mean? So if we have just data plane in this device and control and data plane in the traditional router, it means that this router does not really need to be very sophisticated or advanced in terms of hardware, meaning we can have less CPU, less power, less memory. Every single physical component might be decreased significantly just because we don't need that. We don't need this because this endpoint right here does not need to host control plane. So we can make very lightweight devices, and it's also cost effective because if we want to obtain a device for our edge, for our WAN connectivity, we don't necessarily need to buy a router which is very advanced in terms of hardware and software. We could end up with some lightweight device. That's the benefit, right? So you might say that what is the point of decoupling control plane then? Like, so if I have another router in control plane, isn't it inefficient that now we have two routers instead of just one with two components integrated together and coupled together? You might be right if you had just, let's say, 5 routers in your infrastructure. There is no point of achieving SD-WAN if you have just 5 or a few routers or switches or whatever in your infrastructure. But SD-WAN is adopted by organizations and companies which have at least hundreds of routers in their infrastructure, and they have to manage it efficiently. So this architecture of SD-WAN, decoupling control plane from the data plane, is efficient when you have a lot of routers like that. So let me say, let's think that we have multiple routers like that, and it goes and goes and goes. And now you can basically connect to them. Let's assume we have lines. Yes. And all of them, they do connect to our control plane node, right? That's our control plane. All of them connect to control plane. Now imagine you have like 100 routers, and all of them are managed and controlled from this particular control plane node. So what control plane does in general, it runs a lot of protocols which define the behavior of routing, switching, and in general the function of the endpoint. So by decoupling control plane and placing it somewhere else, far away from these data plane nodes, you can identify one policy here. Let's say you want to configure something. Let's say you have to configure BGP, right? You configure BGP, and this configuration will be sent or pushed to all of these data planes, right? That's a great advantage because if you have, again, let's say you have hundreds of routers, this is a great way of automating your workflow because you don't have to manually interact with every single one of them. That's one of the benefits of SD-WAN, right? But you might ask, what about the other benefits? Like, is that it? Is that it? Absolutely no. So SD-WAN provides other benefits. Another benefit of SD-WAN is that you can pick the WAN circuit you want to use. So as you know, there's a lot of WAN circuit types that you can use to connect to your branch offices, to connect to any other, let's say, office, if you want to establish connectivity with another corporation, another organization. And the traditional problem with that was most of the times to ensure the link reliability, to make sure that the link between, let's say, your branch, let's say you have a branch here, this is a traditional network, traditional router, and let's say there's another router which is in your branch, right? And it is the same router, and they have some kind of connectivity between them. So they have a, let's assume, if I might pick this line, okay, they are connected. Two traditional routers connect to each other, and in the middle they have some form of MPLS circuit, let's say, right? So the problem with this approach is that MPLS links, most of the time they cost expensive, and to make sure that the branch A is reliably connected to branch B, you have to pay for expensive dedicated links like MPLS to make sure that there is uninterrupted and reliable connectivity between those nodes, right? That was the only way to make sure that your data is in transit all the time. But SD-WAN allows you to use other types of transport among multiple branches, right? So as you can see in this picture, let me zoom it in, you can see that SD-WAN doesn't really care about the deployment, the service, the transport, and location. So the flexibility and adaptability that SD-WAN offers to large enterprises, to service providers, to organizations with multiple data centers is immense, is monumental. The flexibility is monumental. So as you can see, right now you don't have to use just MPLS. You can use other internet links, 4G, 5G links, broadband connections, satellite connections, anything. And you can use all of these methods at the same time. So you can build a hybrid WAN, meaning your WAN circuits are not heterogeneous, like meaning it consists just of MPLS. It can consist MPLS plus, let's assume, this is your SD-WAN architecture right here, and you can have MPLS, let's assume here, but at the same time, you can have, let's say, 5G connection here. At the same time, you can have some broadband connection. Now, this is beneficial in terms of, to begin with cost effectiveness, right? So you don't have to pay MPLS for every single link. You don't have to pay for MPLS service. But now, because you can control the link quality and you can monitor end-to-end visibility, you can make sure that your connection is uninterrupted and reliable, right? This visibility and monitoring that SD-WAN provides to you makes sure that you can basically rely on any other service. You can pay less for broadband service, right? Let's say you have a monthly subscription and you have to pay for your MPLS provider every single month, right? And that doesn't make any sense to you, but because it's expensive and sometimes you have interruptions, so it's inefficient at the end. However, now with SD-WAN, you can control and monitor every single WAN circuit you have. Let's say it's your WAN circuit number 1, number 2, number 3. You can control all of them. You can get statistics, you can get operational data, and based on these metrics, you can verify if this is efficient solution for my enterprise, for my organization, whatsoever, right? So this is the cost effectiveness that SD-WAN provides, which is extremely efficient. And the other plus of having separate control plane is that not just configurations, not just like changing the behavior of all your underlying infrastructure, you can actually provide intelligent routing algorithms, processes that automatically reroutes traffic when there is problem with any kind of link. So let's assume that's your control plane, and let's assume you have some interruptions on your MPLS link, right? It collects data from this link, your control plane node, and it sees that the latency value is extremely low. Let's say your latency is around 1,000 milliseconds, right? That's a crazy number, and it just doesn't work for you because you are having lags and the slow speed of internet or whatever. So intelligent routing process embedded on your control plane, SD-WAN architecture allows you to automatically reroute the traffic from this link to the other link, right? So because it constantly collects data from all these links, the link utilization information, the latency, the quality of service, quality of experience, this allows you basically increase your quality of experience and change the links without any kind of manual interaction, right? You don't need a human intervention for that. So that's another plus of SD-WAN. It's really, really smart. The keyword is smart. And that's why this particular control plane in Cisco's implementation of SD-WAN is called vSmart. So let me just name it. This component in Cisco's implementation of SD-WAN is called vSmart. Right, that's your vSmart node. And these nodes are called vEdges. vEdges, as the name implies, they are edge routers. So their primary goal is to basically connect your branches and locations to your infrastructure and to make sure there is full connectivity. So let's talk about vEdge first a little bit. So basically vEdges, as the name implies, they can provide edge-based connections, right? And the advantage of vEdges could be, so they can be software-based, right? In general, I forgot to say, the SD-WAN solution, because it's software-based, all the appliances you can have here, like all the appliances, they can be software-based. So you have your vEdge, it can be a virtual appliance, it can be any kind of virtualized environment run on in standard x86 hardware, right? Or in some VMware ESXi machine. My point is, it can be virtual. It also can be hardware appliance, obviously it depends on your choice, but it can be virtualized. So this flexibility of SD-WAN that you can almost virtualize every single component within its architecture is outstandingly efficient because you don't have to pay for hardware, you don't have to install the box, you don't have to configure the box, you don't have to deploy the box. It's just extremely efficient. And it applies to vEdge and vSmart and also vBond, which is indicated here. I will talk about them now, and vManage, right? They're virtual. They can be 100% virtual and cloud-based, which is absolutely great when it comes to efficiency and cost effectiveness and obviously scalability. So let's talk about vEdge a little bit. Basically, vEdge routers are key component of SD-WAN solution. They are software-based routers that provide connectivity and intelligence at branch offices or remote locations. Unlike traditional routers, vEdge routers are designed specifically for SD-WAN deployments and offer several unique features and capabilities. So, for example, the fact that they're software-based are they run on the x86 hardware virtual machine platform is very efficient, as we already discussed. On top of that, they provide secure connectivity. So vEdge routers establish secure connections over various transport options, such as MPLS, broadband, or cellular networks. They use encryption and tunneling protocols to ensure that privacy and protect against unauthorized access. This secure connectivity is essential for transmitting sensitive data across the wide area network, right? So they can also be used with ZTP, which is zero-touch provisioning. vEdge routers support ZTP, allowing for quick and automated deployments at branch locations. Once connected to the network, the vEdge router retrieves its configuration and policies from the centralized management platform, eliminating the need for manual configuration on-site. Also, vEdge routers have integrated security features such as stateful firewall, intrusion prevention, and VPN capabilities. These features provide an additional layer of protection to the branch network, ensuring secure communication and preventing unauthorized access. So, as you can see, there's a lot of advantages to vEdge routers, right? As you can see, we have, let's actually indicate that because it's very important. Number one is cost effectiveness. I'm going to indicate the benefits of SD-WAN here that we have discovered so far. Cost effectiveness, right? Number two, we have definitely scalability. Number three, we definitely have intelligence. Number four, we could say that flexibility or agility let's say agility because it's software based, right? Okay, let's keep this one so far. I'm going to put it right here because it's very important to remind. So those are the advantages of SD-WAN architecture over traditional networking architecture, right? Okay, so let's talk about the vSmart now, the control plane node or vSmart. Basically, vSmart acts as the centralized policy controller for the SD-WAN fabric. It provides a single point of control to define, enforce, and distribute network policies across all SD-WAN devices. Administrators can define policies based on business requirements, application priorities, and network conditions. vSmart uses real-time network conditions and policy information to make intelligent routing decisions. This ensures that critical applications receive the necessary bandwidth and performance while maximizing the utilization of available network resources. vSmart is responsible for creating and managing overlay tunnels within the SD-WAN fabric. These tunnels provide secure connectivity between vEdge routers and enable the transport of application traffic across the wide area network. vSmart facilitates the exchange of control plane information among SD-WAN devices. It exchanges routing and policy information with vEdge routers, allowing for the distribution of routes, network reachability, and quality of service. vSmart integrates with other components of the SD-WAN solution, such as vBond Orchestrator and vManage Network Management System. Right? It communicates with vBonds for secure device authentication and with vManage for centralized management and monitoring of the SD-WAN fabric. Speaking about these two SD-WAN nodes that we haven't discovered yet. As you can see, I have a picture here of SD-WAN architecture. We already talked about the data plane. Let me actually perhaps zoom in or increase the size of this picture. So as you can see, right, we already talked about the data plane, the forwarding plane. We have underlying infrastructure consisting of edge routers, vEdge routers. vEdge routers could be hardware appliances or software appliances. They do connect using any kind of transport method to vSmart controllers, and vSmart controllers are the control plane of our SD-WAN infrastructure. They are basically the brain of the network, of the SD-WAN network. So this is actually very good, a description of control plane. And let's just put it here so that you can see the vSmart is basically this brain. That's a brain. Cool. So let's continue. Then we have something called an orchestration plane. And the orchestration plane component in SD-WAN is vBond. So let's talk about vBond. What is vBond? Why we exactly need vBond? What it does, right? What's the point of having vBonds on your SD-WAN infrastructure? vBond acts as a centralized orchestration point for SD-WAN infrastructure. Its primary functions include authentication, bootstrapping, and certificate management. Okay, so let's actually write this down somewhere. Let's assume that this is the continuation of our SD-WAN architecture. It might look a little bit unclean, sorry for that. So, and vBond has to connect to the vSmart, right? They have to connect because that's how it knows about new devices in the network. So I'm going to copy that. I'm going to say vBond. And vBond is basically connecting all the new onboarded devices to our SD-WAN fabric. So if there is a new device, let's say we have a new device, we just deployed this virtual appliance, let's say it's a vEdge router, and when it onboards to our SD-WAN infrastructure, it has to authenticate with vBonds. The first step is authentication. You must be authorized device if you want to be a part of our SD-WAN infrastructure. That's the bottom line of it. So when a new device, as we already said, comes online, it needs to authenticate itself before joining the SD-WAN fabric. The device initiates a secure connection to vBond using TLS. vBond verifies the device's identity, ensuring that it is an authorized and trusted device within the SD-WAN fabric. Then we have a bootstrap process. After successful authentication, vBond provides the necessary information for the device to bootstrap itself. This includes the IP addresses of other key components in the SD-WAN fabric, such as vSmart controllers and vEdge routers. This information enables the device to establish secure connections with other components in the network, right? So basically, when this newbie device comes to our infrastructure or wants to be a part of SD-WAN infrastructure, it has to first authenticate with vBond. And if the authentication is successful, vBond will provide some information to this new device about the vSmart, where it's located, what is the vSmart IP address, and other vEdge nodes. What are their IP addresses, right? That's it. And at the end, it does something called certificate management. So vBond is responsible for managing and distributing the digital certificates required for secure communication within the SD-WAN fabric. It ensures that each device has the necessary certificates to establish secure connections and authenticate other devices within the network. vBond provides a dynamic control plane discovery mechanism, allowing devices to discover the IP addresses of available vSmart controllers. This enables devices to establish control plane connections and exchange routing information. So vBond basically is a device which, as the name implies, bonds new devices to the existing SD-WAN fabric. That is its primary function. And recall that because we use the WAN architecture, we have to use public IP addressing to be able to connect to our devices. And in SD-WAN fabric, the only device that requires, must have a public IP address is vBond device, so that new devices can access the SD-WAN infrastructure, can actually connect to it. It requires a public IP address to provide the reachability for new devices that will be onboarded on SD-WAN infrastructure. So that's pretty much it about the vBond. As you can see, it facilitates, it orchestrates the process of onboarding and making sure that all devices are connected and they know about each other in the SD-WAN fabric. And let's continue and talk about the last component of the SD-WAN fabric, which is called vManage. It's located in management plane of the SDN architecture, as you can see on top, or application plane, also sometimes called. And it is basically a management plane software that allows us to centrally manage and monitor our entire SD-WAN infrastructure, right? So let's talk about the vManage in detail a little bit more, what it does exactly. So vManage acts as a central management platform for the SD-WAN infrastructure. It provides a web-based interface that allows administrators to configure and manage all SD-WAN components, including vEdge, routers, vSmart, controllers, and other devices within the network, obviously. vManage enables administrators to easily configure and orchestrate network-wide policies, security settings, quality of service, application performance parameters, and other network settings. It provides a unified interface to define policies, deploy configuration changes, and ensure consistency across the SD-WAN fabric. vManage offers comprehensive monitoring and visibility into the SD-WAN fabric. It collects real-time performance metrics, network health status, application statistics, and other relevant data from the various SD-WAN components. Administrators can view this information through customizable dashboards and reports to gain insights into network performance and troubleshoot issues. vManage generates alarms and notifications based on predefined thresholds or events within the SD-WAN fabric. vManage simplifies the process of managing software images across the SD-WAN infrastructure. And also vManage integrates with other components of the SD-WAN solutions such as vSmart, vBond, and analytics platforms. So it exchanges information to facilitate secure device authentication, control plane coordination, and data sharing for enhanced network visibility and control. As you can see, the vManage is extremely sophisticated appliance in SD-WAN fabric. It makes sure that you have complete visibility of your SD-WAN fabric and you can have complete control over your SD-WAN infrastructure. So let's assume that this is our SD-WAN. So basically we cannot assume because SD-WAN vManage is not a hardware appliance. It's not a router, and also vBond. So these icons might be ignored. So let's assume we have another icon, right? We assume this icon, and this is our vManage node, right? This is our vManage node. And vManage basically controls entire infrastructure, right? That's what it does. And the best way to describe the vManage within a few words is single pane of glass, which allows you to see and monitor everything. That is vManage. So these four components are part of Cisco's SD-WAN implementation. Cisco used this precise architecture because they at some time, I think it was like in 2011 or something, they acquired a company called Viptela, which were already like implementing this SD-WAN solution. And they acquired this company and they turned SD-WAN to their own solution from that company. And that's how they implement this technology. They have four primary components, which is, again, vEdge, the data plane, vSmart, the control plane, vBond, the orchestration tool, which connects all other components of SD-WAN, and vManage, the management plane tool, which allows for easy monitoring and management of entire SD-WAN fabric. As you can see from the picture, the same thing here. And as you can see, vBond, vSmart, and vManage are inside the cloud, meaning they are cloud-based solutions. They can be deployed and activated anywhere in cloud. Only the vEdge routers must be present on the data plane, meaning they have to be part of your branch, right? So as you can see, this picture here, this architecture of SD-WAN is just all about efficiency. It eliminates all the problems that we were facing with traditional networking architecture, as you can see from here, by just decoupling control and management plane from the device itself and implementing it on the cloud. We can have crazy efficiency, which will allow us to efficiently secure our connections. So in terms of security, I haven't identified the security here. It's extremely important in modern networks, and this is what it provides. This is what SD-WAN provides. This benefit is huge, right? And yeah, and let's talk also a little bit about vAnalytics. vAnalytics basically is a part of vManage, and as the name implies, it provides analytics data to measure the SD-WAN, current SD-WAN fabric infrastructure, how everything goes, how the flows are processed, you know, all the operational data. You can have a lot of visualizations to basically see and determine what happens in your network real time. So as you can see, this is also a very facilitating tool that is integrated in the SD-WAN fabric stack solution. So that's pretty much it. I hope this video was informative for you. It was insightful. Perhaps it brought some light towards topics that were unfamiliar to you. To summarize, again, as we already discussed in this video, SD-WAN provides several benefits in comparison to traditional networking architecture. The cost effectiveness, the idea that you can pick any kind of transport, any kind of service, and you can efficiently use them. You can use all of them. You can make sure where your routing appears, where your traffic flows. You can have data to monitor it, and you can determine which is the best path. Then you have a scalability, meaning to onboard new devices is extremely easy. You can basically obtain a very cheap vEdge node because it doesn't have a control plane in it. It consists just of data plane. And after obtaining that, you can introduce this device to vBond, and vBond will take this device, authenticate it to your existing SD-WAN fabric, and will make sure it is connected to the rest of your infrastructure. And as you can see, it's a very scalable solution, because if you want to obtain, let's say, a new pair of 50 devices, all you have to do is basically introduce it to vBond, and it will take it further and make it the part of your infrastructure. The intelligence of vSmart, the brain of the SD-WAN infrastructure, the control plane of SD-WAN fabric, the intelligence that it provides is it can determine which links are not as promising as they should be. They are constantly monitoring and collecting operational data from link utilization statistics, and they can intelligently reroute traffic to make sure that you have uninterrupted traffic flow and minimum downtime. The agility, the fact that almost all of the nodes can be deployed in virtual fashion, meaning they are all software-based virtual appliances. All you have to do is just deploy a new VM or virtualization, any other virtualization technique to make sure you have this device up and running instantly. And last but not least, I believe security, the fact that all data transmission happens over TLS tunnels, make sure that your traffic is safe and secure in transit, and it cannot be easily compromised and altered. And all these benefits are provided by SD-WAN, which is a modern and future-day networking solution for wide area networking. Thank you for watching this video. I hope it's been informative. If you liked, please don't forget to subscribe to my channel. In the next video, we'll be talking about SD-WAN REST API interfaces, and we'll cover some basic and maybe advanced API calls to the SD-WAN vManage node. Thanks. Have a nice day. It's been a pleasure.